Assalamu alaikum students and welcome to another lecture of Slate. This is Khawaja Yasin. Let's study chemistry. In the last lecture of chemical energetics, we discussed the important definitions that the students encounter and they have to memorize for chemical energetics. Now, moving on to the very next concept, the calculation of enthalpy change. What is enthalpy change? What do we remember? It's delta H. And what else? The unit. Because if you remember the unit, the calculations will become easy for you. Kilojoules per mole. So, you've done different ways to calculate enthalpy change. For instance, one method involved enthalpy change equals to enthalpy associated with bond breaking minus enthalpy associated with bond making. Now that was one formula. Even there was another formula where the enthalpy change was equal to enthalpy of products minus enthalpy of reactants. This can be applied in the concept of Hess law. But in this lecture, we're going to talk about another very important formula, which is Q equals to MC delta T. A very important formula for P2, yes, but for P3, more important. Wherever you get the enthalpy change calculations, that's an important formula, students. So Q is the heat, just the heat content, mass, M, C, specific heat capacity of water, and delta T is temperature change. So, Q is the heat energy in joules. Mass. Okay, let's talk about temperature change first. Now here I say, it can be in Celsius or Kelvin. Why? Because this is change in temperature. For instance, if I have a temperature value, let's say, initial temperature and final temperature, and the delta T will be the difference. So if I say initial is 50 degrees Celsius and final is 60 degrees Celsius, the change is delta T is 10 degrees Celsius, obvious. If I convert it into Kelvin, 273 plus 50, that would be 323, and this will be 333. So even in Kelvin, it is 10 Kelvin. So temperature change is always the same, be it Kelvin or Celsius, because you're adding 273 on both sides. So we can't stick to degrees Celsius. Now the important part, mass of the substance. And here we talk about mass of water. And water ke case mein you have to assume that 1 centimeter equals to 1 gram. So you have water, you have the volume of water. You use it in grams. You assume that 1 centimeter is 1 grams. Then specific heat capacity of water. Now, we are taking the mass of water, we are taking the specific heat capacity of water, which is a constant, 4.18 joules per Kelvin, joules per gram per Kelvin. Now, in this case, examiner can give you the value as 4.2, or sometimes even the value was 4.3. This is the value given at the end of your exam. So you can incorporate the value given by the examiner or the value given at the end of the exam, the formula sheet. Now one thing, we are talking about the mass of water You have the specific heat capacity of water. Now, what is the temperature change? Even the temperature change is that of water. What do I mean by that? Like if I say I have a polystyrene cup, and I take a thermometer here. This is the water inside. For instance, it can be anything in aqueous medium. So we're using something in aqueous medium. So what is an endothermic reaction? The energy comes from surrounding to the system. And exo is the exact opposite. But what about water? Students, the water, or I would say aqueous medium, is the surrounding. Water is considered as the surrounding. The system or particles you cannot see, like chloride ions, sodium ions, we cannot see those particles. So if the reaction is endothermic, so it would gain energy from the surrounding. Not just this surrounding outside, but surrounding, water is the first surrounding. So in endothermic, energy goes from water to the system. So, in the case of endo, temperature of the water decreases. So all you need to remember is that water is a surrounding. In exo, system gives out heat and water gets warmed. So exo mein, temperature of water increases. So that is why this whole belongs to water or solvent. This whole equation belongs to water. The mass is of water, not the reactant. It's always of water, always. So, this is the first step. So, we have calculated Q in joules, but we want enthalpy change in kilojoules per mole. So, I would first convert joules into kilojoules and divide it by the moles. But moles of what? This time we talk about the moles of the substance reacting. So, delta H, this is step number 1. This is step number 2. So delta H is Q divided by the number of moles reacting. So we divide Q by 1000, we get the value in kilojoules, and divided by the number of moles reacting. So remember one thing, water does not react unless neutralization. Because in neutralization we talk about 1 mole of water. Remember, in that case we talk about water. In this case, in other cases, water is just a solvent. So water does not react. So remember, a solution has a solute and solvent. So water is more in quantity. So solvent has this calculation, while solute has this calculation. Sorry. This number of moles reacting. Now these are of solute. So above value is for solvent of water and there's solute. Now let's solve a past paper question. When we talk about calorimeter, I have a diagram here, sorry, yeah. That's what happens. I burn spirit or ethanol here. it is undergoing combustion, and ultimately the combustion is increasing the temperature of water. And water will tell us the amount of heat difference. And obviously, if I 0.4 gram of ethanol raises the temperature of 100 gram of water in a calorimeter by 21 degrees Celsius. So this is the temperature change. So calculate the enthalpy change. Simple. Step number 1. Q equals to MC delta T. M is 100 gram, that's of water. We don't talk about this mass. Remember, this will come later for moles. So 100 into 4.18, and this is temperature change as it raised the temperature. So into 21, and the answer will be, let me calculate, 8778 joules or 8.778 or just 8.78 kilojoules. That's the value. Now, I need to incorporate this Q in the delta H formula. Q divided by moles. So Q is 8.78. Moles of what? Moles of this ethanol. We have the mass, we have the name. Easy. How to calculate the moles? N equals to mass over MR. Mass is 0.4. MR of ethanol, C2H5OH, 12 plus 6 plus 16, 24. That would be 46. So this divided by 46, and the value of moles will be 0.0087. Now we divide it with this value. .78 divided by, and the value will be 0.4 gram divided by 1009.1 kilojoules. And it raises the temperature of water. So it increased the temperature of water. So if this increased the temperature of water, this means this has given out heat. So this would be an exothermic reaction. That is something you need to calculate yourself. In the other formulas, we easily find out the sign, but here we need to calculate it ourselves. Now let's do another question. This is a different question. In an experiment to measure enthalpy change of neutralization, 1 mole of water, when 50 centimeter cube of HCl is added to 50 centimeter cube of NaOH, both 1 mole per dm cube, the temperature change is 6 degrees Celsius. We remember, enthalpy of neutralization is always exo from the definition. Calculate enthalpy change of neutralization. Simple. Same formula. Now students, this is 4.18. This is 6.0. What about the mass? We need the mass of water. We don't want the mass of HCl. We don't want the mass of NaOH. So I've drawn this diagram for you. If we have 50 centimeter cube of HCl and 50 centimeter cube of NaOH solutions, both the solutions are aqueous, and both of them are made in 50 centimeter cube of water. So ultimately, the total volume of water is the sum of these two volumes. This is the case for all the enthalpy change and neutralization reactions. The mass of water will be the sum of volume. Like you have a conical flask, you add volume from the burette. You have 25 centimeter cube in the conical flask, you add 21 centimeter cube from the burette. The volume of water will be 25 plus 21 because both of them are made in water. So the total volume of water is 100 centimeter cube. So the value will be 2508 joules or 2.51 kilojoules. Now, the moles of reactant, I told you one thing. In this case, in neutralization, is about water. You need to find out the moles of water here. But how? We'll have to make this equation HCl NaOH, and they will tell us about the moles of water. 50 centimeter cube, both are the same. Both have the same moles. One mole per dm cube. So I can use any value. So 0.05. So 0.05 moles of HCl or 0.05 moles of NaOH forms 0.05 moles of water. So now I use these moles, the moles of water, because in neutralization, it is about water. Standard enthalpy change is Q divided by N. Q is 2.51 and N is mole of water. I would write it for you. Divided by 0.05. So the answer in this case, students, will be 50.2 kilojoules per mole. And guess what? It's the enthalpy of neutralization. Even though they say it's at temperature change, they don't tell you if it's being raised or not. You should know that enthalpy change of neutralization is always exo. So negative. That you have to add. Last question for combustion. In an experiment, 1 gram of hexane was completely burned in air. So this is the mass of hexane. We use similar technique or calorimeter. We can use anything. Was completely burned in air. The heat evolved raised the temperature of 200 gram of water from this value to this value. They have given values in Kelvin, doesn't matter. All we need to do is Q equals to mc delta T. So mass is 1 gram? No. Mass of water. So 200 gram into 4.18 and temperature change 345.1 minus 293.5. $51.6, and I'm going to multiply this by, the value becomes 43137.6 joules, or so 43.137 kilojoules. Now we have the value. Similarly, we need to find out the moles of hexane. So N equals to mass over MR. 1 divided by hexane, C6H12. So 72 plus 12, 84. To find out the moles, we divide 1 by 84. 0.0119 moles. Last step, again similar. Delta H equals to Q divided by N. So 43.137 divided by 3625, or you can say to 4.9596 kilojoules per mole. But two things. One, did it increase the temperature? Yes. So it means it's an exothermic reaction. Or even if you don't know about it, completely burned in air, we're talking about a combustion reaction. So the negative sign should be added by you. So that is how you're going to solve the questions of enthalpy change of different reactions through the Q equals to MC delta T formula. In the next lecture, we are going to talk about Hess law, a very important question for both P1 and P2, most commonly occurring question. It is a little tricky, but we are going to make it easy for you. So thank you so much. Take care and Allah Hafiz.